How do we do that? I see two terms. I see this piece is common to both. Out 3/2 times 3 times e to 3t. These are out. The denominator is e to 3t minus 1. But now the least common denominator here is 2 the square root of e to 3t minus 1. So I need to multiply this by it. So I have 2 parentheses e to 3t minus 1 minus e to 3t. I promise from the get-go, the second derivative will be very messy. Okay, so finally, 9/2 e to 3t, and let's see what we have here. And then I flip the denominator. So I have 2 e to 3t minus 1 and the square root. I don't think that this is really necessary, but it's a problem we chose. But what I'm saying is, for the scope of this course, I think this is a little bit stretching it for what we're trying to do. But since we chose it, we have to finish it. 2 e to 3t minus e to 3t is e to 3t, and then minus 2. And this is it. No one can do anything. So I'm really happy with the first derivative. I will ask you for the second derivative, but not for a situation that is so algebra involved and flipping and this and finding so much. So this is very important, of course. But finding the second derivative, not on something like this. I think it's a little bit stretching it. Okay, so I like us to look at word problems now. Okay, so let's see what we're interested in looking at. So we have some functions here, and they are calculating. They're giving us the graph, and they want something. Let's also. I couldn't hear you.
Could you go back to the answer of that problem? I couldn't get it down in time.
Yes.
Thank you.
You mean this?
Yes. Yes, ma'am.
So 3e to 3t, I took it in front to make my life easier. Then I realized that the least common denominator, there is no denominator here, it's 1. The least common denominator and the numerator is 2 the square root. But I need to multiply this by 2 the square root. So then I have a 2 outside, and when I multiply these two, I get 3e to t minus 1. And then minus e to 3t. And now the least common denominator is 2 the square root of e to 3t minus 1. This is over 1. So I have to flip it, because that's what I do when I divide two fractions. So I keep it 2 e to 3t minus e to 3t, which is e to 3t, but 2 times negative 1 is negative 2. So this denominator is now here. This denominator is now here, because I flipped this. And I copy the rest. 3 times 3 is 9. 2 e to 3t is, of course, in the numerator, is not in the denominator. It would be 1 over. But this is over 1, of course. So this is the final simplified form. No one can do anything else to it. And there is nothing we can do to simplify anything here. You could, if you wanted to put this as a 4 in front, you could do that. That's fine too. But nothing else will work. If you want to write it again, it's 9 e to 3t, e to 3t minus 2, 2 times 2, 4, parentheses, e to 3t minus 1, and the square root of the same thing. Is this better?
Yes, ma'am. Thank you very much.
Thank you. Other questions on this? Anyone? Okay, so let's go back. I'd like to look at some more problems. At least one, just to see how maybe depreciation, the function is given to us. We just want to answer some questions. And of course, they have something to do with derivatives. Memory retention, that's another limit in there. We're not going to graph, so please do not graph just yet. We're going to deal with graphing plenty in chapter 3. So let's choose a word problem so we can move on to the log function. Any preference? Okay, I will choose then, if no preference. Medication concentration, why not? Okay, I'm on page 6, 53. The concentration C in parts per million, C in ppm of a medication in the body, T hours, T in hours. I always take notes on what I need here. Is given by the function, finally C of t, thank you very much, 10 t squared e to negative t. So these are functions that are more, have more application. What we just looked at, it was a perfect exercise in practicing and differentiating, but something like this is really difficult to work with, I would say. Okay, perfect. So we are given the function. Find the concentration after 0, 1, 2, 3, and 10. So T, 0, 1, 2, 3, and 10 hours. Okay, so C of T, this is part A. This has nothing to do with calculus. That's why I like to plug in the function. So first of all, I see it, and etc., etc. So 10 t squared and an e to negative x. Good. I have the function. I see it. It's 10t squared minus e to negative t. Fine. And second end table. And I want 0, 1, 2, 3, 10. 0, 1, 2, 3, and 10. And I copy everything. Just go. You have to go back and highlight. I don't know how many decimal digits we want. Concentration, let's say 2 decimal digits. So in that case, I don't really need to highlight anything. So 0 for the first one, 3.68. For 2, 5.41. For 3, 4.48. And 0.05. Where is my book? Okay. Use a calculator to graph. No, there is no need. Find C of 5 and C prime of 5 and explain what those values represent. So, C of 5, why didn't you tell me from the beginning? Just tell me 5. Okay. So C of 5 is, I'll add it here at the end, 1.68. Fine. What is this? Well, so C of 5 equals 1.68 ppm represents, anyone wants to help? Represents the, what is C? Is anyone paying attention?
I don't remember.
Okay.
What was the word problem?
That's okay.
I got numbers on the brain.
That's okay.
Okay, so the concentration.
Good. Awesome. The concentration after
5 hours.
That's it. Okay, so this was part B actually. Now they're asking us to find C prime of 5 and interpretation. what do I have to do first in order to find C prime of 5? What is the first thing I need to do? Can anyone tell us how would I?
Did you find the derivative of the function?
Absolutely, absolutely. So we have to find C prime of t first. Excellent. So 10 can wait outside patiently. This is function 1 and this is function 2. So what do we do? Can anyone help? Anyone else I haven't heard from, please? Anyone? Please? I'm begging nicely.
Is it first function prime
Yes, 2t times the second
times
one.
the second
Excellent. Plus,
first function times second function prime?
yes, e to negative t times the inner function prime. What is the inner function prime? Anyone? Anyone would like to help? What is the inner function prime?
Wouldn't it just be like 1, -1?
That's it. Awesome. Thank you. Good. Let's see if I can do anything here. I don't think so, but I'm just going to rewrite it. I can factor out t e to negative t. So 10t e to negative t. T is out, e to negative t is out, only 2 is in. Negative. 1t is out, e to negative t is out, so 1t is left in. The way I like to write it is negative 10t e to negative t, t minus 2. I'm allergic to negative leading coefficient. You can say, is this really necessary? You're only asked to find C prime of 5. Yeah, as a matter of habit, I recommend you always simplify and have the nice form handy. Okay, so C prime of 5 is not a big deal. I just have to plug in 5. But what will it represent? So first of all, we're going to get a number. I need the measurement unit and what it represents. What will be the measurement unit, first of all? Maybe you want to find a number first. Let's find the number first. Okay, my second function is negative 10t e to negative 10, e to negative t. And then in parentheses, t minus 2. I'm checking my function one more time. Negative 10t, yes. E to negative t, yes. T minus 2, yes. And then I only want to determine this, and it should be already there. It's right here. I just copy the number. Negative 1.01. It's right here for 5. Y2. Good. So then what is the measurement unit, which has to be there always, always, always. And what does it represent?
The change in?
Very good. Yes. So the change, the rate of change, of concentration with respect to time when t equals how much? 5 hours. Awesome. What is the measurement unit? So this one is the concentration after 5 hours. This one says, this number says that the rate of, this is the rate of change of concentration with respect to time. And when t is 5, the rate of change is negative. so it's decreasing. But I need the measurement unit.
This could be wrong, but is it ppm per hour squared or no?
Very good. Just per hour. Awesome. This was ppm. This is the rate of change with respect to time. The rate of change is the measurement unit for the y variable and over the measurement unit for the t, or the independent variable. Y over x. Measurement unit for y is ppm. Measurement unit for x or t is hours. Excellent. It's a rate of change. It has to have two measurement units. Awesome. Thank you. Perfect.